All right, so we're going to finish up our notes, the 3-1 notes from yesterday. So yesterday we ended with this problem, which was kind of a good little crash course and some trig review. So yeah, hopefully everything in here made sense to you. We started out by doing our derivative. We got our 2 cosine x minus, and then the derivative of the outside. Cosine is sine, and then the inside stays the same. And then times the derivative of the inside is 2. And then we had to use our double angle identity for sine, which was 2 sine x cosine x. Factored, we found our zeros, we made up our table, we plugged all those values in, and we found that we had a relative max here at this pi over 2 comma 3, and a relative min here at these two values. So it's not in the front of your book, but it is in that PDF version that I stuck on the classroom, and I just wanted to kind of put some of these things up here. Hopefully this doesn't look too blurry to you guys and you can see this. Some of these things you know, you've seen these before, this is nothing new, but I just wanted to put some of these identities up here. So if you're not sure about them, you can have them now in your notes or whatever. So feel free to pause this and write any of this stuff down that you don't know. So all of this stuff you guys seem to know very well. Your opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, and then all of their reciprocals. The circular functions, this seems to be the way that you guys were doing them in different quadrants. This over here is your unit circle, so this is what I'm referring to when I talk about the unit circle. You don't really need to worry about that a whole lot other than the fact that basically you are doing that when you're doing the circular functions over here. So anyway, that's what the unit circle looks like. Some of these identities, reciprocal identities, I think you guys know those. You seem to know those pretty well. But here's the double angle identity, and this is the one that we had talked about yesterday for sine. Cosine has 2 of them, right? There's cosine squared minus sine squared of the angle, whatever u or theta or whatever you want to look at. Or, I mean, I guess really it has 3 of them depending on how you manipulate this equation using your Pythagorean identities. So, I mean, you could look at it this way or you could look at it this way, and again, that would all just depend on how you are factoring or something, you know, that will determine which of these 3 forms for the cosine double angle you use. There is one for tangent, but you could also just do sine over cosine and get the same thing. Your tangent, cotangent identities, these are also known as your quotient identities, which you know that sine over cosine equals tangent. Pythagorean identities and the sum and difference identities we had talked about with when we were doing the limit as h approaches 0 of sine, when we determined that the derivative of sine was cosine. We had talked about those. But anyway, like I said, I wanted to just put these on here. They are in the front of your PDF version of the textbook, but they are not in your physical textbook. So, and there are more. I just cut out the ones that I know you'll see and you'll need to know. So, if any of these things look foreign to you, write them down and just start memorizing them because they are something that you're expected to know coming out of pre-calc or trig. All right, so let's finish out these notes now. Excuse me. So what we did not finish yesterday was this concept of absolute extrema, which basically just means we're no longer looking at an interval, we're looking at everywhere from negative infinity to infinity. Do we have an overall lower value or an overall higher value, highest value, which would give us an absolute minimum or an absolute maximum. So looking at this graph right here, whatever this graph would look like, this kind of like wavy, whatever, parabola looking thing, it would have a minimum, right? We would have an absolute minimum. We have a lowest value right here, but we would have no absolute max because it goes up forever on both of the endpoints. If we look at a linear function, whether it's a linear function going this way or a linear function going this way, that would have no absolute max or min because it's always going up in one direction and it's always going down in another direction. Okay, so that would have no absolute max or min. And we could have some other functions that look like this, where we would have an absolute min, the overall highest value this would be right there. And then we would have 2 absolute mins in this point, or in this graph, because we have 2 points right here that would give us the same lowest y value. So we would have an absolute min there, and 2 absolute mins, and an absolute max. Again, we have open intervals here, so this would be like one section of the cotangent graph, and basically this would have no absolute max or min. Again, looking at an open interval, if we were to close this, let's say if we were to like move this in here a little bit, and we have a closed interval at A and B, we would have closed intervals here that we could find with our endpoints, but we're not really looking at the overall, or we're not really looking at that closed interval, we're looking at an open interval, so it's a little bit of a problem there, and you can see that what I'm talking about here. With any function, whether it's linear or some kind of curve, if we close off the endpoints and we make it a closed interval, then those endpoints would give you a max or a min, or one of the values in the middle, where you had a derivative equal to 0 would give you a max or a min, okay? So that's basically the only difference, and that's what we're going to talk about here. So here it is, basically same thing, just written out in words instead of in graph form. So if you want to pause that and write those down, and then we'll do these examples. All right, so this is very similar to the example that we had done, or the examples that we had done in class yesterday. So this is nothing new here. We're just going to refresh your memory and then get into some newer examples. So first of all, we have our endpoints, 1 and 5, that we'll use in our table. And then we're going to find any zeros that we have, and we're going to use those values as well. So take the derivative of this, 6x squared minus 30x plus 36. So when I set this equal to 0, I recognize these are all divisible by 6. So I'm just going to go ahead and do that, divide everything by 6. And then 0 divided by 6 is still 0. Okay, so save me a little bit of writing there. So factor. This factors to x minus 2, x minus 3. So I have 2 zeros at 2 and at 3. Okay, so when I do my table, okay, I need, since both of those values fell between 1 and 5, I have to use them. So I'm going to use 1. My lines are crooked. 1, 2. Wow, that was terrible. Let me try that again. Getting rid of too much. All right, 1, 2, 3, and 5. Okay, so 1 and 5 are from your endpoints right here. 1 and 5 are from the endpoints. 2 and 3 are from setting the derivative equal to 0. Okay, so we don't need to try 4. We're just doing the endpoints and then all the values that give us a derivative of 0. So, excuse me, we're going to take those values, 1, 2, 3, and 5, plug them into f, not f prime, plug them into f, so we're going to plug them in here, and we're going to see what we get. So, I'll just fill in the table. 1 gives you 23. You can try these on your own if you want to pause it and try and see if you get the right answers. For 2, I got 28, 3, I got 27, and 5, I got 55. Okay, so, excuse me, we have a min there at 123, but also, let me back up a step, because all I'm asked for are the values, find the extreme values. We're not asked to find the extreme, we're not asked to find the points or anything, we just need the values, so that's just the x values. So there's a min at, there's a min at x equals 1, and there's a max right here at x equals 5. Okay? Now, those are absolute maxes on the interval, or when you have an absolute maximum on an interval, that's kind of the same thing as a relative max and a relative min. So what we're going to look at here in these next two examples are, we're now looking at the entire the entire graph, so negative infinity to infinity, so infinity. So we're looking at the entire thing. We're not looking at just, a certain section of it. We're looking at the entire graph, okay? So as soon as my board decides to work here, there we go. So first thing we have to do is find our derivative. So f prime 2x cubed, the derivative of that would be 6x squared, minus the derivative of 6x is 6, the derivative of 2 is 0. So factor this. 6x plus 1, x minus 1 equals 0. So I have two potential, keyword potential, maxes and mins, max or mins, okay? So now I'm going to do same thing. I'm going to make up a table. -1 and 1. So let's plug them in. Plug -1 into the function. What do you get? Well, -1 gives you a -1, and +1 gives you 0. Okay? So, this is a potential min. This is a potential max. The question is, how do we determine whether they are absolute maxes or mins? So really what we want to know is what happens when we look at negative infinity and what happens when we look at positive infinity. Okay, now we can't just plug those in and get some numbers, right? But we do have a concept that we can use, and that concept, hopefully you know, is limits. So we're going to take the limit as x approaches negative infinity of this function, f of x. And what do we get? Well, if we plug a negative infinity, really big negative number, into that function, okay, really big negative number. Wait a second, I'm looking at the wrong table. Let me back up. This is not -1. This is not 0, sorry. I got my problems mixed up. This will give you a 6 and a -2, sorry. Looking at the wrong table. Okay, so we need to look at what happens when we plug in negative infinity and what happens when we plug in positive infinity. So if I plug a negative infinity in here, again, we're just looking at the highest power, so we can kind of ignore the rest of this. If I plug a really big negative number in here, what do we get? We get negative infinity. If I look at, sorry, need my limit there first. If I look at the limit as x approaches a positive infinity of this function, what do I get? Again, I'm only looking at the highest power. Well, that gives me a positive infinity. So what that means is that when we looked at the values all the way to the left, our negative infinity values, we got a negative infinity. So all the way out here, if this, let me see, like let's say if this is my coordinate plane, my negative infinity values, all of these values out here, gave me a negative infinity. They were going down forever when we looked to the left. When I went to the right, they were going up forever. And then I had these two values here in the middle at -1 and 1. So like, let's say what, -1, 6, 1, -2, something like that. So, right, so this would be my point here at -1, 6, and this would be my point down here at 1, -2. So the question is, do we have an absolute max or a min? And the answer is no, because overall in this graph it goes down forever, so there's no absolute min. It's continuing to go down forever. And we have no absolute max because this is continuing to go up forever on the right-hand side. Okay, so this graph has no absolute max and no absolute min. Okay, there are relative max and mins. We would have a relative max right here and a relative min right here. But overall, absolute means the entire graph. There is no absolute max and no absolute min. Okay? Next example. First of all, take the derivative. F prime of x equals 12x to the third plus 12x squared. I'm going to factor out a 12x squared. 12, not 2, and then I'm left with x plus 1. Want to find out where that's equal to 0. I have two potential zeros, well, two potential max or mins, 0 and negative 1. So let's go to our table, negative 1 and 0. So here we go. This is where I had the negative 1 and 0. Looking at the right table now. Same thing. I want to know what's happening all the way to the left, what's happening all the way to the right. And in order to do that, we have to bring in limits. So limit as x approaches negative infinity of this function, f of x. Well, what happens when I plug, again, I'm going to ignore all the smaller powers, I just want the highest power. What happens when I plug a negative infinity in here? Well, a negative number to the fourth is a positive, so this will be a positive infinity. Limit as x approaches infinity of same function. If I plug a positive number in here, positive number to the fourth is still positive, so I have positive. Okay, so again, if I look at my graph, I know the numbers to the left were positive infinity. I know the numbers to the right were positive infinity. So at negative 1, I had this dip here at negative 1 to 1, and then 0, 0, it kind of flattened out and then went up again. So this right here, this value, is my absolute min. Okay, there is no absolute max because it goes up forever. This value here at 0, 0, it did flatten out to give us a 0, but it still continued up, so there is no absolute max in this case. Okay? All right, let's keep going. Now, for this one, what I want you to do is pause the video, label A, B, C, D, E, F, G, and right next to them whether they are an absolute max, absolute min, relative max, relative min, or neither. So go ahead and pause, do that real quick, and then we'll see what you get for your answers, see if they match up with what I have. All right, so A, because we're looking at the like a closed interval, there is a filled in value there for A. This is the entire graph, so A would be an absolute min. That is the overall lowest value that this graph is ever at, is A. B. Now, B is not your absolute max. I mean, G, there could be some values in here. Do you see like where B kind of goes across? Let's see if we can draw a line across here. If that was a straight line there, you see how there's some values in here that are higher than B? Okay, so B cannot be an absolute max, but it can be a relative max. Okay, so relative max. C is nothing. Okay, C is, that's a 0. That's not a max or a min, so that's neither. D, well, we already have, you can't have more than one absolute min or absolute max unless they're at the exact same point. So D is a low point here, but it would have to line up with A for you to be another, for it to be another absolute min. So it's not an absolute min, but D would be a relative min. So relative min. E, don't let E and F fool you. Those are not maxes, relative max and mins. Those are neither. And I'm going to categorize these the same because they fall under the same category. Okay, so I'm going to group them together. They are neither because you have this sharp turn here. Okay, there is a cusp at those two values. So while they may be critical values, they are not a max or a min because the derivative would be undefined. Okay, and the last one, G, again, don't think G is an absolute max because it's an open circle. Remember, that only applies to closed intervals. So this one would also be neither. That is not a max or a min. Okay, so your absolute max would fall somewhere in this category between wherever B lies. If B is right here, you know, it'd be somewhere in there, but it's an open interval, so really, you know, we can't look at that absolute max or min because it has to be a closed interval and it has to be a continuous function. So we have a hole there, so G is neither as well. All right, so what I want to do now is just take some time and show you how to do this on your calculator. So go ahead and write those down, and then what I'm going to do is I'm going to pull up the calculator, and I'm just going to graph these and show you how to do these on the calculator. So go ahead and write those down, pause the video, write them down, and then we'll put them on our calculator. Now, some of these you would be able to do by hand, not some of them. The first one you could do by hand, but the second and the third one, because we have two functions in there that you are not familiar with finding the derivative for, the exponential function and ln, we can't do that by hand just yet, but we can do them on the calculator. So let's plug these in. First one, 8x minus x squared. What do we get? So let's graph it. I don't know where my window's at. All right, I can't even see it, so I'm going to have to zoom out. So let's do zoom out 3. All right, so now I can see it all. All right, and you can change your window. You could do like -5 to whatever. It doesn't matter. Okay, you can change your window around if you want to. And actually, let me do that. Let me change the window because we're only looking from 0 to 6. So let's say let's go one further. So let's say -1 to 7. And let's graph that. So it's going to make it look a little more flattened out. So we're going 0, 1, 2, 3, 4, 5, 6. That's all I care about is right there. So if I'm trying to find the max and the min, if we look at this graph, now we're only concerned with here at 0 to 6 right here. So we can see that the min is going to happen right here at 0. So we can see that the min here is 0, 0, right? Hopefully you can see that. The min is 0, 0. But the max is going to be right here. Now we can kind of look at this and see, all right, well that looks like it's at 1, 2, 3, 4, and then who knows what the y value is, but we can see that maybe the max is right here. So the way that we do that, if it's not a nice whole number and it's a decimal, is we want to go up to our calc. So we're going to go second calc, and we want to find the max. So just press the number 4, and it's going to have you find the left side. So we want to go to the left side. So let's say right there. You have to be able to see where the max and min is. The right side is there. It's going to say guess. We're not guessing. Hit enter. Now, when you see this, 4.000032, this is a rounding error for your calculator. This means 4. Okay, so the max would be at 416. So that would be your maximum value. Your maximum value would be 4, and your point there would be 416. Okay, so there's your maximum, and your minimum would be at 0, 0. All right, let's do the next one. So let's clear this one out. X to the third e to the -2x. I'm going to change my window from 1 to 4, so let's go one step further, and 0 to 5. Let's graph this. I don't know. Yeah, I thought that's what's going to happen. So let me change the window now. We don't need to go 40. That's a little bit of an overkill. Let's do -5 to 5 and see what that. That's still a little bit. Let's just go -1 to 1 so we can actually see the whole thing. Okay, and sometimes you may have to do this. You look at the graph and you're like, I still can't really see what's happening here. There we go. Now we can see. So, first of all, our max. We can see that our max happens around here. There's no way we're going to be able to guess that, so let's have the calculator do it for us. So calculator max. So we got to go to the left side, left bound first. So move your little spider guy over there. All right, so I know I'm to the left of the max right here. Let's go to the right. I know I'm to the right of it there. Enter. 1.4999996. So I'd say that's pretty good estimate there will be 1.5. Okay, so you could put 1.500, and then the y value is 0.168. So that's your point for the max. All right, so our min, we're going from 1, right here is 1, to 4, 2, 3, 4. So hopefully you can see that 4 has the smallest value. So you have two options there. You can either take that function, x to the third e to the negative 2x, and you can plug 4 in and see what you get, or we can just come over here and we can do second calc. We want to find the min. So, well, we have to be careful here, actually. Let me come back to the graph. Because if we're looking at just 4, you see as we go past 4, it's continuing to go down. So I don't know that I would really necessarily use my graph for this unless if we put our min, what we can do is if this is going to depend on where that cursor falls. If we can get that to fall right at 4, then we should be okay. So here's our left bound. We'll hit enter. I just don't know that we're going to get this to hit right at 4. See, it jumps right over 4. So we know because we have that right bound on our interval, we have to go to 4, but our calculator won't let us do that. So what we're going to have to do is we're going to have to come back to our main screen, and we're going to have to type 4 into this. So 4 to the third power, which you could just write 64, e, and then we're going to say negative 2 times 4, and we're going to see what we get. So 0.021. Your calculator may have given you that when you use the 3, if you used like around the value of 4, and you use like that 3.97 or whatever it was, and then the 4.015. The only problem with that is 4.015 is lower, so it might give you a value that's a little bit off from this, but it'll still be close. But that's your exact value there. X value would be 4, and the Y value is that. All right, so let's come back here. One more, 5 ln x squared plus 1, close parenthesis, minus 3x. My window, I'm going 0 to 4, so let's take it a little bit further. Negative 1 to 5 looks good. I'm just going to say negative 5 to 5 for now until we see what this graph looks like. We may need to adjust it. Okay, so I think that's all right. So here's 0, 1, 2, 3, 4 up here. All right, so you can see that we have a min down here and a max up here. So our endpoints will not be our maxes or mins. So let's just do this one here real fast. The min, 3. Keep clicking over, over. So here, I know I'm to the left of my min. Go over. I know I'm to the right of my min. There we go. There's your minimum, 0.333, and the y value is negative 0.473. And the max, over. Keep going. We know that it's somewhere around 3, and it may be right at 3, but I mean, it looks like it's pretty close to 3 at least. So here I know I'm to the left. Enter. Over until you know you're to the right. Enter. So the max is at 3, and the y value is 2.513, rounded to 3 decimal places. Okay? So there's how you do it using your calculator for those calculator problems. And again, you can rewind that, ask me any questions if you're not sure about any of those things. And last slide here is the homework problems that I think I gave you yesterday, but there they are just in case you did not get them. There you go. All right, so if you have any questions, just let me know. Otherwise, we can talk about this a little bit more on Thursday and go over some more stuff. But if you have any questions, just let me know.